October, November 2022, Paper 2, Variant 2. Question 1. Okay, species such as ammonium carbonate phosphate, they are example of the molecular ion. Okay, and part A. Ionic and covalent bond both involve electrostatic attraction between different species. Okay, identify the actual species that involve in these electrostatic forces. Okay, so first one, ionic bond. Ionic bond is quite easy. When they ask you to draw the lattice of ionic bonding, so you should draw at least like this. Make sure the cation and anion, they are arranged alternately, and the positive and negative particles, they will have the electrostatic attraction. As long as the attraction between positive and negative particles, so the force always we will call electrostatic attraction. Okay, so therefore, in ionic bond, the species that involve in these electrostatic forces, they are cation and anions. Okay, in the covalent bond, okay, you need to know for the covalent compound, okay, they have one or two or more covalent bond. So we need to understand the nucleus of the atom. Okay, it will attract the bonding electron. So they will attract the bonding electron. And in the covalent bonding, because there is attractions between the nucleus, which is positive, to the bonding electron, which is negative, so the nature here is also electrostatic forces. So that's why in the covalent bond, the species that involve is the shared pair of electron, means this pair, and the two nuclei, means the, okay, for this example HCl, so the is attraction between the two nuclei with the bonding electron, right? That's the electrostatic forces in covalent bond. Okay, part B, just complete the table according to this ammonium carbonate and phosphate. First, you need to calculate proton number. Okay, so is for ammonium is 7 plus 4, so you get 11. Okay, because it's a cation, so it will have one electron lesser, so the total number of electron is 10. Okay, this one 1 mark. And carbonate, so it's 6 plus 24, proton number is 30, so 2 negative means it gains 2 electron, so 30 plus 2, so it becomes 32, 1 mark. Okay, phosphate, 15 plus 32, so you get 47. Because it's 3 negative, it gets 3 electrons, so that's why it's 50, 1 mark. Okay, part C. Ammonium is a bronzed acid. Define what is this acid. Very easy. As long the species can donate proton, then we call this species as bronzed acid. Okay, proton donors, yeah, is the bronzed acid. Okay, when the ammonium is heated with sodium hydroxide, a pungent smell is produced. So the pungent smell refers to the ammonia. So ammonium, okay, with hydroxide form ammonia and water. The nitrogen atom in ammonium is sp3 hybridized. Okay, so before hybridization is look like this. So s orbital has 2 electrons, p orbital has 3 unpaired electrons, and these 4 orbitals, they will hybridize, means they combine, and it will form 4 identical hybrid orbitals we call sp3. Means in this one, in this diagram, it has 4 sp3 orbitals, and these 3 unpaired electrons will use to share with others to form a normal sigma bond. This lone pair is going to donate to others to form the dative bond. Right? That's why hybridization of the nitrogen, okay, in ammonia or ammonium is sp3. Okay, very easy. Part 3, the drawing. 2s, you just draw a circle. Right? It's very cool for this orbital. And 2px, so x is important. You must draw the 2 lobes along the x-axis only. Okay, this is very easy. D part 1. Name the anion PO43 negative. So this one you should know, at least you should know, is a phosphate. And what is the oxidation number now is important. So overall charge is 3 negative. Oxygens we have 4. So negative times 4 is negative 8. Negative 8 overall charge is 3 negative. So P must be positive 5. Okay, so therefore we know that it's going to call phosphate 5. 5 means the oxidation state. Okay, so now we have this compound, right? The hydrated and anhydrous compound. Okay, molar mass given 245.3, and now it's asked what is the numbers of molecules of water of crystallization. Okay, for this compound we know that 1 mole of this hydrated compound, it will form 1 mole of anhydrous and x mole of water. This is the equations that you at least need to know before you calculate. Okay, molar mass for this anhydrous, the salt, so is 1, after you calculate, you should get 137.3. This one is anhydrous without any water. So we use the hydrated salt, the mass minus the anhydrous will get the mass of water. So this is the mass of water, mass of H2O. Okay, then use the mass that obtained over 18, you get the moles of water. Right, so we know that it will form 6 water molecules. Okay, part E. Hydroxide aqueous reacts with 2-bromo-2-methylpropane. This is tertiary haloalkane. In SN1 reaction, the molecular ion, the CH3, bracket 3, C positive, form as the intermediate in this reaction. Draw the mechanism for the SN1 reaction. So between the hydroxide and the 2-bromo-2-methylpropane. Include all the charged dipole, lone pair, curly arrow, and so on. Okay, so first you must show the tertiary haloalkane undergo bond breaking. So CBr bond break, you just need to draw 1 arrow from the CBr bond to the bromine. Okay, remember, must put the dipoles. Do not put charge positive and negative. Must put this delta positive, delta negative, means partial positive, partial negative. Okay, after the bond break, so it will form the bromide here, and the carbocation ions form. Then hydroxide with the lone pair on oxygen. This lone pair, you must draw an arrow from this lone pair, point to the carbon or the carbocation ion. So means it's going to form a new bonding with this C. This O going to form new bonding with this C, from this product. Right. So hydroxide, the oxygen with lone pair with this arrow 1 mark. Okay, then of course the correct product is 1 mark. Okay, part 2. 2-bromo-2-methylpropane. Okay, as I told you just now, tertiary bromoalkane. Define tertiary bromoalkane. Very easy. Okay, the CBr carbon, this carbon, is bonded to 3 other carbon atoms. That's the definition on this tertiary haloalkane. Organic compound M forms when 2-bromo-2-methylpropane is heated with ethanolic hydroxide. So we know that is elimination. So the mechanism is this. Hydroxide will now attack the hydrogens on adjacent carbon. Okay, this is a carbon with bromine. So the hydrogen that bonded to the adjacent carbon will removed. Hydroxide will attack this proton, CH bond break. This pair of electrons move to the CC to form CC double bond. At the same time, CBr bonds break. Okay, and these electrons will move to the bromine to form bromide. So at the end, it will form this methylpropene, water from here, and the bromide. So it will form 3 products. But now it's asked the organic compound, means the methylpropene, right? This one. Okay, so that's all. Thank you.